Hello children, in this video we are going to see the 8th chapter in Cbse class 9 science. The topics in this chapter motion are regarding motion, rest, distance, displacement, scalar quantity, vector quantity, speed, velocity, acceleration, graphical representation of motion, and the derivations of equations of motion and uniform circular motion. In this video, we'll be seeing the first few topics. So what is motion? When an object changes its position continuously with respect to the position of other objects and with the passage of time. So here we are comparing the movement of the object not only with respect to the other objects but also with respect to time. Then the object is said to be in motion. When you talk about motion, automatically we also need to say what is rest. So when we say an object is going to change its position, it is motion. Then if it does not change its position with respect to the other objects or with respect to time, then we say that the object is said to be in rest. So these are the two concepts of motion and rest. Next, let us see what is a reference point. So when we learned the definitions of motion and rest, we saw a word with respect to the position of other objects. So we are comparing the position of an object with respect to some other object or with respect to some other position. That position is called the reference point. In this picture you can see that if this is going to be taken as the reference point, then this person is going to be at a distance of 2 meters, whereas this person is going to be at a distance of 3 meters. Suppose if this reference point is going to be changed here, then you can say that this particular person is at a distance of 5 meters, whereas this person is exactly in that point, and you can say that there is going to be only 0 meter distance. So what is this reference point? A reference point is used to describe the location of an object. So an object can be referred through many reference points. That's what we saw here. This is one reference point, this is another reference point. Okay, but generally we consider the reference point to be a stationary object. When we talk about rest and motion, we saw that with respect to some object, generally it is going to be stationary, but not mandatorily. Okay, so when we consider two reference points for a same object, then we can say that the same object at rest can also be considered to be in motion. So look at this picture. This is the picture which you have. Okay, so here you can see that this person is inside a train or a bus. So he is in motion. He is in motion, but he is moving along with the train. But what does he feel? He feels that the natural scenery which he is looking at from the train is moving very rapidly as the train or the bus keeps moving. So we can say that these objects are at rest, but now when compared to this person in the train or the bus, he feels that these objects are going to be moving. So from this we can say that rest and motion are relative. So even in this picture you can see that this person is at rest and this person is at motion. Okay, but when you ask this person if he is moving, he will say that he is at rest. But when we look from outside the train, we feel that both these people are in motion. So with this we can say that with two different reference points. So when you have the reference point here, you can say that he is at rest and he is in motion. But when you take a reference point outside the train, then you can say that both the people are in motion. So an object can be considered to be in rest and motion when it is compared with two different reference points. So thus we can conclude that rest and motion are relative. Okay, when you say rest and motion are relative, you say something keeps moving, we automatically can conclude that when an object is moving, it will cover a certain distance. Okay, so what is this distance? So for example, you start from here, okay, you need to reach this place. So here they have showed a path like this. Okay, they have showed a path like this. It is not mandatory that you have to go only by this way. You can even go through a way like this, or you can go through this path. Okay, so this distance is going to talk about the total length of the path. Okay, it is going to talk about the total path length. Okay, it is not going to talk how you are going to travel, which path you are going to take. It just says whichever path you may take, that will the length of that path will give you the distance traveled. So now here, look at this. You are going to start from this particular point. You can see this person is going to move to the library. Okay, and then he comes back to the cafe. Okay, so now if you have to calculate the distance traveled by him once he reaches the cafe, then you will say the distance traveled by him is going to be 100 meter plus this 45 meter, and also the 45 meter which is going to travel back again. So which is going to be 190 meter. So this will be the distance traveled. And one more important point is that distance can never be 0 or negative. It can only be positive. Because if you say it is 0, then it means that the object is at rest. If an object is at rest, can it cover any distance? No, it cannot cover any distance. Next we have to learn about displacement. You all know the word misplace. So when you keeps a book on a particular place, for example, so this is your table. Okay, so this is your table, you place your book here and you go out and you come back and you look for a book here. For example, it is moved to another corner of the room somewhere here. Okay, so you do not know how this book went there. Okay, you do not know how this book went there. Okay, but the only thing you know is that you have the book here now. It is not where you kept. So your question will be, who misplaced my book? You will not ask how did the book go there, or you will not be bothered about the path it took. You will only be bothered about that it was in this particular position, but now it is here. So displacement talks about the shortest distance. It talks about the shortest distance. So you can take any way. You can see it's going to be, this is going to be the start and end. See, you can travel through this path, or you can travel like this, or you can travel like this. But displacement talks about the shortest distance measured from the initial to the final position of an object. So you can see that here, see the displacement, it keeps on changing as this person is going to move, because the shortest distance is going to move continuously. So this is what we talk about when we learn the displacement. See here we see that this person is going to travel here 4 meters and then is going to travel this way 3 meters. So distance will be what? Your 4 meter plus 3 meter, which will be 7 meter. But when you want to calculate the displacement, this will be the shortest distance. So the shortest distance you can calculate from the Pythagoras theorem. So which will be root of 4 square plus 3 square. So that you will get it to be root 25. So which will be 5 meter. So the same thing you can see here also. The path taken talks about your distance. The shortest distance talks about your displacement. The same picture is there given in this way. So with this we'll complete this video. We will learn the next part of this lesson in the next video. Thank you, students.